Hey, last week we did a practice math Olympiad, and at the end of practice there was a question about this particular problem. We didn't have time to really go over it, so I'm going to try and explain it now. If you have questions, you can ask at practice. But the first thing I think that is confusing about this is that it's squares, triangles, and circles instead of letters of the alphabet like we're used to. So I'm going to rewrite it as square equals S, triangle equals T, circle equals C. You could do anything you want. You could do X, Y, Z if you wanted to make it look more familiar, but for me it's easy to remember square, triangle, circle. So I have, rewriting the first equation, I have square plus triangle plus 2 circle equals 15. The second one is square plus 2 triangle plus circle equals 19. The last one I have 2 square plus triangle plus circle equals 14. So I have 3 variables, 3 equations, and there's several different ways we can solve this. So I'm going to show elimination of variables first. So I would take we're going to add up the last 2 equations. So I have S plus 2t plus c equals 19. 2s plus t plus c equals 14. And so if I add those together, I get 3s plus 3t plus 2c equals 33. Okay, so now if I take that equation, 3s plus 3t plus 2c equals 33, and then I subtract the equation I didn't use, s plus t plus 2c equals 15. I get 2s plus 2t equals 18. So then I can simplify this. S plus t equals 9. So now we just have 2 variables. So now I can go back to this first equation up here. S plus t plus 2c equals 15. Now I have an s plus t here and an s plus t here, so I can swap that in. 9 plus 2c equals 15. Subtract 9 from both sides. 2c equals 6. c equals 3. All right, so now we've got our first variable. So then we can go to the second equation. S plus 2t plus c equals 19. But c is 3. S plus 2t plus 3 equals 19. S plus 2t equals 16. But then I have from up here, s plus t equals 9. So if I subtract those, I get t equals 7. And if we have t equals 7, s plus t equals 9, s plus 7 equals 9, s equals 2. So now I've solved all three variables. And then I can plug it in the question asked for. 3t plus 2s. So that's 3 times 7 plus 2 times 2 equals 21 plus 4, 25. So 25 is the answer. I also want you to notice, so when we had s plus 2t equals 16, and s plus t equals 9, if we had to add it instead of subtract it, I would have gotten 2s plus 3t equals 25, which is what they were asking for, without having ever to actually solve for s or t. So that's one way to do it. Another way, if we write the three equations at the top of our page again, s plus t plus 2c equals 15, s plus 2t plus c equals 19, 2s plus t plus c equals 14. Okay. And so I'm going to write up here what we want is 3t plus 2s is the question. All right, so if we add all these up, we'll get 4s plus 4t plus 4c equals, these add up to 48. So now if I divide that whole equation by 4, I get s plus t plus c equals 12. So now if you notice, each equation up here has 2 times one variable. So if we go s plus t plus 2c equals 15 minus s plus t plus c equals 12, we'll get c equals 3. If we do s plus 2t plus c equals 19 minus s plus t plus c equals 12, we get t equals 7. And then if we do 2s plus t plus c equals 14 minus s plus t plus c equals 12, we get s equals 2. And so we want 3t plus 2s equals 3 times 7 plus 2 times 2 is 25, which is the same answer we got before. Now on this one, I could have skipped this step because I never needed C. I could have just done the bottom two and saved a little time. There are other ways to do this, but it's algebra. So that's it. If you have any questions, let me know.